Welcome to this event. I will start because the event is mainly using fuzzy cognitive mapping, which is a modeling techniques to explore agricultural system in relation to human health. But the first thing that we need to start with is to do an introduction to what is a farming system, what is farming system analysis. So I'll start with the definition of a system. What is a system? We have that definition of Arnold in 2015 that define a system as a group of combination of interrelated, interdependent, or interacting elements forming collective entities. You can also define a system as an ensemble of elements interacting with each other for a certain purpose. And there have been some axiomatic that have been defined by Merali, 3 axiomatic for something to be called a system. So the first one is the existence of a distinct entity that can be identified and explicitly defined as the system or the whole. For example, a farm. The composition of the whole from a number of interconnected parts. And the third axiomatic is the existence of distinctive properties that can be ascribed to the whole, but not to any of the individual parts that constitute the whole, meaning that the whole is more than the sum of its parts. So what is a system made up of? A system is made up of components. You have the element of, the component are the elements the system is made up with. You have the structure of the system. That's the way these components are interconnected. You have the boundaries of the system. So the boundaries are the limits of the different subsystem and the system as a whole. So the definition of the system boundary really depend on the scale and the purpose of the study that we will see in the different examples in this presentation. You also have input for a system. So inputs are not very part of the system, but they are exogenous elements that can influence the system. And you also have output that are generally element or products leaving your system. So I'll go with an example. Here, I start with a system with 2 components. So the soil and the river. So in the soil, as a component, I've put some example of subcomponents, earthworm, fungi, water, mineral element, and you have all those sub-elements interacting between themselves in the soil. You also have the river. I simply put the fishes and the plankton as the elements of these subsystems, and they are also interacting between themselves. So for example, if you take vegetation, you see that vegetation grows actually on soil. So you have an interaction between vegetation and soil. And you also have interaction between terrestrial mammals and that exploit vegetation, and also the animal or the resources that are in the water. You have now human farmers that exploit the soil, the vegetation, the hunters that will be more interested on terrestrial mammals, the fishers more on resources on the river. And you may also have interaction between these 3 people, the farmers, the hunters, and the fishers. You have interaction between them because they can, for example, they can exchange information, they can exchange food, they can exchange money, and so on. And here is the system boundary. So this is really a fictive example to show you a bit what we can call a system. So inside you see the different component of the system here that are the soil, the river, the vegetation, the farmers, the fishers, and so on. And you also have those blue arrows that show you that they are interconnected. This is very important. You need connection between the different components of your system for it to be called a system. And you also have your system boundary, okay, the limit of your system. And the limit of your system really depends, as I said previously, on the scale and the target of your study. Now I'll add the input, because I also talk about input. So as an input in my system, I can, for example, say there's rainfall, seeds for the farmers, and fertilizer. And as an output, output is everything leaving the system. So we can say hunted animals, crops, and fishes. So this is an example of a system based on the different elements that I presented on the previous slide. So why do we do system analysis first? So in general, the system approach helps us to deal with complexity in time and complexity in space. More specifically, the system approach helps us to deal with a non-linearity. So you have, generally when you are studying a system, you have different elements with multiple dynamics in the system. You have path dependencies, which means that in a system, what happens at the time t depends on what happened at time t minus 1. For example, if you take a farmer that last year tried to grow sorghum, for example, in an area, and it's a new crop and it didn't work, it is highly probable that another year he will change the crop that he's growing. So this is what we call path dependency, that what happened in the past influence what is happening now, and what's happening now will influence what's happening in the future. And the system approach helps to deal with that too. Another property is the emergence. So what we call emergence is a global pattern of a system that cannot be predicted from the properties of its parts. You also have self-organization. So it's kind of organization that appears in the system without a central authority controlling it. And very important, you have the interactions. As I already said, the system is often composed of many interactions, which impact on the system can be difficult to apprehend. And last, you have adaptation. So the system can adapt or can cope with change. You can see, for example, in our farming systems, farmers deal with climate variability, for example, by using early growing crops. Those crops that do not take a lot of time to grow, for them to avoid the drought that can occur during the rainy season. So after now defining what is a system and the different components of a system, I'll now try to give a definition to a farming system. According to Ken Giller, a farming system is defined as a population of individual farm systems that may have widely differing resource bases, enterprise patterns, household livelihood, and constraint. So a farming system is defined as a population of individual farm systems, and this farm system exhibits varying degree of interdependencies and interact in the use of common resource properties. This is really important. This means that it's a population of farm systems, a farming common resources. The diversity of the farm and enterprise requires that development strategies, intervention, and policies need to be tailored to the different needs and opportunity. And now that we have defined what is a farming system, that's a population of farms that are using common resources. So a farm system, according to Fresco, is a decision-making and land-use unit comprising the farm households, cropping and livestock systems that transforms land, capital, labor into useful products that can be consumed or sold. So here I go with visualization of a farming system so that you get more familiar with the system. So now the first element of farming systems, the crops, of course. So when I say the crops, I consider the crops, but also the soil. You have the livestock subsystems, and you have interactions between the crops and the livestock system, because generally in our system in sub-Saharan Africa, the crop residue are used to feed the livestock, and also the manure produced by the livestock is used to fertilize the field. You also have the environment, mainly grassland, in which livestock usually graze and also can deposit the manure there. So these three elements, I can call them the resources, and those resources are managed by households. And that thick black line that you're seeing is actually a representation of our system boundary. So in our system, you have the crops, the livestock, the environment, and the household members managing those resources. But out of the farm systems, you also have this household unit that is also interacting with the market, buying and selling, interacting with other households in the same area. And you have the input and output in the system. As input, we can say the light, the rain, heat. And that as an output, we can say the greenhouse gas emission from livestock production. So now we go to farming systems analysis. So farming system analysis can be understood as the understanding of structures and function of farming systems, the analysis of constraint on agricultural production at the farm level, and research programs. So the key characteristic of a farm system, we will say, first you have its structure. So by structure, what I mean the material, for example, the tractor, the cart, etc. The household size, you have the cultivated area, the herd size and the composition of the herd, the cultivated crops and the dedicated land to each crop. And you also have the contribution of farm revenue to the total income. This gives you an idea of the degree of diversification of the farms. You also have the function, the functioning of the farms. You have the biomass, fodder, grain, and livestock management. You also have the resource allocation between material, crop, and livestock. Input cost in by input, I mean fertilizer, irrigation, water, fodder, concentrate to feed the livestock, etc. So here I'm going to present you a bit the different steps and associated methods for farming system analysis. So first, you have the first step is a description of the biophysical environment. So description of the climate, soil, water, and the economic activities. And you can do this using literature, data, GIS, and remote sensing data. And this really concern, I mean, the scale of this is really a region, okay? It's not a village, it's a region. And this description of the biophysical environment, if you have a program or a project, help you to define the pilot area in which you are going to perform your studies, mainly the agroecological region in which you are going to work. Second, you have to see the diversity of the farms in the pilot areas. So to do this, generally, you proceed with farm typologies based on survey and or focus group discussion. This can be defined as a meso scale, but we are still at the regional scale. The third step is the definition of research question in relation to the problem identified with farmers in pilot focus group discussion with farmers. It can be done at local scale with villagers. And the last step is the exploration of possible solution to the research questions. And to do this, generally, you can proceed with experiment, farm experiment, trial, still at village scale. So for farming system analysis, cropping subsystem, or for each of the subsystem, you have the component, the input, the output, and some indicators of performance. So the components, as Lucille has said, there is soil, yes. You have the crops themselves, the weeds, the insects, the microflora and the microfauna. As an input in the cropping system, and what we use to crop, you can understand it like that. We have the seed, the nutrients, let's say the fertilizer, manure. You have water, labor, pesticide, and herbicide. As an output from the cropping systems, of course, you have grain, you have crop residue in the cropping system through the grain, the crop residue, and also through the soil, and you also have water. The indicator, I've put in some indicators that are often used to access the performance of cropping systems. You have the nutrient and water budget. So a budget is broadly what is entering minus what is going out. So input minus output, if you want. You also have the nutrient use efficiency. For example, the nitrogen use efficiency, which is the nitrogen output and divided by the input. You also have soil organic carbon, microflora and fauna. Okay. For the livestock subsystems, you have for your animals, fodder, concentrate, water, labor, medicine. Output, meat, milk, manure, and greenhouse gas from those manure. And as indicators, you can say livestock water productivity, which is the amount of water that is used to, for example, produce 1 kg of meat. You have also the nutrient use efficiency, the amount of greenhouse gas emitted, and the milk productivity. In the household subsystem, the component are the household members, input, seed, grain, fodder, meat, money, etc. Output, almost the same thing. And indicator, you have the energy consumed by the household versus the energy required. This gives you a bit an idea of the food security. We also have on-farm and off-farm income and security of food shortage in the household. So I'm going to give you some example of in Sub-Saharan Africa of studies of farm system analysis. Generally, it starts with a typology of farms. As I said previously, it gives you an idea of the diversity of farms that exist in your area. So if you look at the slide here, you have 4 farm types. So farm type 1. First thing I said, the total area cultivated, you can see that there's a difference between them, 0.5 hectare here to 2.8 hectare here. Now you also look at the allocation of land to the different crops. For example, for farm type 2, you can see that there is a part of the land that is allocated to tea production, but you don't have it in the other systems. And here also you have the animals in kraals, meaning that farm type 1 and farm type 2 are actually more into intensive production of livestock compared to farm type 3 and 4, where you have the animal that's typically grazed. And there's also the interaction you see between the different farm types at village level. So you use this information that you get through survey and focus group discussion to build a representation of your system. So this is a representation of the system in that study. Livestock and soil, and very important, the interactions between them. Inputs and the output. So generally you use those information and combine it with modeling. This is what they did. They use this information in a model called FarmSim. It's a macro model. Experiments with trials, and you take this information and you can use explore with farmers with this information. So we're going to go into a very small exercise. I'll ask you to make a group of, I wrote 4 to 5 people, but given the number that we have, I would say 3 to 4 people. And I'll ask you to make a graphical representation of a farm system with an emphasis on human health, and to prepare a short summary, something like 5 minutes, presenting the structure and the functioning of your systems. But first, if you have questions, you can ask.
How can we make the graphical representation? So throw more light on that.
Okay. Thank you for the question. The graphical representation, you only you do it in Word or PowerPoint. What I call a graphical representation is really something like this. You see, this is a graphical representation of a farm system, but okay, it is not a farm system, it's just like ecosystem. And I want you to draw, based on the information that you have now, your representation of a farm system in relation to human health. So you basically draw the different components of your system. Now you can use arrows to show the interactions between them. What is the boundary of your systems, the input and the output of the system? Is that more clear for you?
Yes, it's okay. It's okay.
A graphical representation of your system. So what you are asked to do is you say your farming system in relation to human health. For example, you have in your farming system, you have the crops, you have pesticides, you have water, you have human health. This is an example. Are you with me?
Yes.
So if you take each element of your system, you represent each element of your system in small boxes, like crops, pesticides, human health, water. And then you take arrows to connect the different boxes to show interactions between the different boxes. And when you are done, you draw a boundary. You draw a boundary on your system. The boundary limits the system and allow you to represent what is coming in your farming system and what is going out. And I advise you to do this in PowerPoint. Like one of you start sharing his screen on PowerPoint and you start drawing the boxes and the arrows. Do you understand?
Please, if that's. Can you repeat the element of the system?
But I just gave some example. It is to you to find, I mean, according to your overview of the system, but I gave some examples, the crops, the livestock, pesticide, water, human health.
Okay.
See, so you find this element. You are not obliged to include all of them, but I'm asking you to, if you have 10 elements in your mind, put them and put the connection between the different elements. Draw some boundaries, input, output. Chinelo, I can't hear you. Or is that Chinelo or not?
It's her. It's her.
Okay, so you are working with Chinelo.
Yeah.
Ah, okay.
Under the inputs, we have rainfall, we have seed, we have fertilizer.
Yeah.
We are trying to take a typical system. Maybe you can take the seed. What seed are we looking at now? Or can we work on rice? What are you working on in your PhD?
I'm working on animals, birds.
Animal. Then let's use the animal system, because you know the system is divided into two. We have the farming, the livestock system, and the farming system. Since you're working on animal, let's go to livestock system.
Okay. Okay. Yes. Right like that.
Under the livestock, that's the presentation. So under the
animal system.
Okay, the next this thing now is animal system. You're looking at livestock. Livestock.
Yeah, livestock.
That's a livestock farming system. So as a typical example of our system we are looking at? Example of the animal.
For example, if you have birds.
Birds, okay. Birds.
Birds are there because here we are talking about wildlife.
Okay.
Animals.
Okay, wildlife animals.
Yeah.
Okay.
Yeah. So we have the ecosystem, which is the forest.
Yes. Ecosystem.
And the soil.
They live in.
Yeah.
The soil.
Yes. The soil.
Yes.
Yes. The diet.
The what?
If we take birds for example.
Yes.
Birds.
Yes. You mentioned
the diet is composed by grain. Grain.
Okay, grain. Okay. Because they feed on grain, right?
Yes, they feed on grain.
Okay.
Also on seeds.
Seed.
Yeah.
Seed is not part of the grain.
No.
Okay,
They feed with also with seeds.
Okay. Seed,
Water.
water,
The air.
egg.
Air.
Can you spell it?
A. E.
E.
Not E. I.
Okay,
R.
L.
R. Yeah.
Okay, that's air. The one they breathe.
Yeah.
Okay. That's another component, yes.
Yeah. Now we can talk about different ecosystem in the forest, the habitat.
Hello here. Hello.
Yeah,
Hello.
we can hear you.
Yes, I'm here. No, first thing is that you have a new member here, or two. I don't know. You have Espoir Gaglo, which is also one of the speaker of the day.
Okay.
So, and you have Confidence.
Okay.
Who is there too? I don't know if you are already chatting.
All right.
Yes, we are chatting. We are exchanging.
We have like Christelle, she mentioned that our components will be livestock. So we are looking at components of livestock farming system.
Okay. Please, if you have, the exercise is don't bother yourself too much, because the exercise is to think about the farming system in relation to human health, as I said, and all the different elements that you have. Just put them into boxes, okay? These animals, okay, one box is fertilizer, one box is manure, one box, and you connect all those elements together to show the interactions. Now you draw a boundary, because you need a boundary for your system. Say, okay, this is the boundary of my system. This is what is coming in my, and this is what is going out of the system. I've heard someone mentioning forest. Please don't go too much into forest. You can, but stick to agriculture and human health.
Okay.
But I don't see your presentation yet. I've sent the file, the presentation to everyone. Have you seen it?
Not me.
I've sent it in the chat.
Let me check.
I can't find anything.
I can't find it.
You can find in the file. Look at the chat, please.
Chat.
Hello, everyone. You talk about this chat or another chat?
Okay, you don't see it. Wait. I will it again. It seems that I have to send it to each group. Now I've sent it now.
Better.
Did you see it?
I have to stop this share. Sorry, I got a call. I left. I needed to put somebody.
Not for the moment.
I've stopped the share. You can now share it.
I shared it already. Look at the chat.
Okay, chat. Okay.
Yeah.
It's good now.
It's good now.
Yeah,
Okay.
that's the PDF, but you already have the PowerPoint, Chinelo, so you can see it. Espoir, welcome.
Thank you. Good morning, everyone.
Yeah. It seems that everyone is busy in the group, but exercise is quite simple. You can find the exercise at the end of the presentation. Is to represent a farming system. I gave some example in the lecture. You can see those boxes of elements of the farm connecting together, the boundary of the system, the input and the output.
I can
We
hear
asked
you.
to work on a components of a farming system.
Okay.
You represent it in boxes in order to show typical system analysis. So you mentioned birds. That should be,
Yes.
we have birds, which are wildlife.
Yes, in a system, you need interaction between the component of your systems. So where are the component of the systems? Now the input, the output, the boundaries of the system. I don't see all these elements. You see? Are you with me?
Yes, 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 yes.
Okay, so a system, you have component of your system. For example, if you say livestock systems, I don't know, what is livestock system? Maybe it's a mistake. But life, water, that's a component of a system. Pesticide, that's a component of a system. Soil, that's a component of a system. So you take each one of these components, you put them together to have interactions between them. Then you draw your boundaries. Your boundary allow you to know what is coming in to your system and what is going out from the system.
I will present our job in agroecological system. That's we have soil, crop, water, mineral element, microorganism, manure, insect. We have many interaction in crops with mineral elements, microorganisms, insects. Also, we have livestock. We have a cow, small ruminant. The family will get a crop resource and also livestock resource. After we have the limit of our system. In environment, we have inputs such as rainfall, mineral fertilizer. We have some outputs like crops resource and animals resource.
Okay, but going back to the presentation, I have something to say is we said that we are going to connect farming system with human health, and I didn't really see that connection in the presentation. There were a lot of elements of a farming system, crops, soil, livestock, interconnected, but the relation with human health was not clear. Otherwise, the main element of the system, as we discussed this morning, are there. There were different components of the system. There were interactions, and there were also system boundary, input and output, and those are the main component of a system. And we could see that in the exercise. Very good. So we move now to the presentation of Dr. Emmanuel.
What we have here is component of farming system. We call it component of farming system. If you look at the interaction, you see the extension officer being the key player in this component of farming system. We have soil, we have water, fertilizer, and crop as part of the components. And here, extension agent is a kind of change agent that got information, have access to information from the research institutes, who transfers this information to farmers through some improved techniques and improved farming system that will benefit the farmers. In that way, the farmer will be able to a kind of practicalize that experience he got from the extension officer to be able to work on his livestock. He'll be able to work on his crop in area of some farming mechanisms. And in area of fertilizer, the extension agent will be able to impact the way of applying fertilizer to the soil to be able to help the farmers to make an increased yield. When all these components were put in place, you will see that the human health, there will be improved in human health, because all these things will lead to increase food security in the society that will directly or indirectly affect human health. Thank you. I'm true.
Okay. Okay, thank you. Thank you very much for your presentation. It was very interesting. I really like the fact that, I really like the fact that you included access to information and also the extension officer into your system. But I wonder why you spotted the different element of the system in different colors or boxes, because I can see black colors, but something like gray or white. For example, fertilizer, if you look at fertilizer, it's not the same thing. Did you do it on purpose, or it's just, or it just doesn't mean anything?
Is it where?
I said that the font that you use for livestock, for example, is different from crop.
Okay, you know, when you talk of fertilizer, you add fertilizer to the crop to improve the yield. Part of the crop, like fodder, you will use it to feed the animal.
Okay.
Hello?
Hello, can you hear me?
Okay, can I come in a bit?
Yes, I'm hearing two questions.
Okay, just to add to the question you asked, as regards the different colors and shapes, actually it was an oversight. It didn't mean anything specific.
Okay.
Yes, it's just an oversight. And while we're trying to beat up it, we didn't have the time to readjust and ensure that we have everything in square boxes and then dark colors.
But now, can you give the explanation of the link between the extension officer and the soil, and the extension officer and the fertilizer?
Okay. When you look at the explanation, you know, the role of extension officer, part of it is to teach the farmers on the best application method of fertilizer.
Okay.
The role also, part of it is best farming practices.
Yes.
The role of extension agent is to teach the farmers on best way to handle the soil to give its optimum yield, to be able to help in improvement of the crop, to give it optimal yield. So the extension agent is like a change agent at the center of farming system research. They are the people that transfers information. They are the key player in agriculture. They are the people that transfer the information to the end users. They transfer the information to the grassroots level. They'll go to research institutes, go to university, go to some companies to get a kind of best technology. And their duty is to transfer it to the farmers and teach them also way of practicing it. And also at the end, they will get a feedback from the farmer, whether positive or negative. Go back to researchers or subject specialists to be able to bring out the results. Thank you.
Yeah, thank you for your explanation. Now I understand that because the way I understand what you're saying, but the way it is run is like there's a direct interaction, extension officer and the soil, which can be true in some cases because, for example, if they're exploiting the soil to perform some kind of experiment or we don't know. But now what you have explained is more like they are in connection with the research world and then they transfer that knowledge to farmers. So you, instead of that, you should have drawn a direct arrows from the extension officer to the farmer directly, and then also feedback arrow from the farmer to extension officer.
Yes.
Apart from that, thank you.
Okay.
Yes.
Yeah. Is there any question from the rest? Do you have questions? If anyone have questions.
No, I don't really have a question, but so I think I have some commendations and some clarifications.
Yes.
Yeah, first I want to
Okay,
commend
go on.
Yeah, they did a very wonderful work here. In as much as you made the corrections on how the arrow should be directed, I think the approach the group brought in here is the area of information dissemination, and that's exactly part of what we'll be talking about tomorrow, the relationship between these fertilizers and pesticides and human health, and then the role of the extension officers, the role of the extension officers on teaching the farmers on the safe application of the best practices in pesticides and fertilizer applications, and then the relationship with crops, because sometimes farmers in Africa, they believe that the best way to increase yield is to apply more and more fertilizer without looking at even the pesticide, without looking at the negative implications to the environment, and then which trickles down to human health. Yeah, I think they did well by bringing in this approach, and I commend them seriously.
Thank you very much.
So good afternoon, everyone. I'm Espoir Gaglo. I'm PhD student at Cheikh Anta Diop University in Dhaka. So I'm in Senegal. My research focus on modeling approach of vegetation climate interaction in agroforestry systems in Sahel. So the objective of my research is to develop decision tools based on future climate prediction. So today, today my presentation will focus on the following points. So first, I will briefly review the concept of farming system, I will give you an overview of the all system presence in Africa and how the system are impacted by climate change and what kind of strategies different actors set up to face with climate change. So there is many definition of climate change, but I found Kengular definition quite representative, and as he say, population of individual farm system that may have widely different resource base. Uh, to keep it easy for our understanding, we can consider farming system as an integrated set of activity that farmers perform in their farm under certain resources and circumstances to maximize their productivity and their income, and on some sustainable basis. So in our continent, we have about 15 major farming systems. So the system take account many components such as soil, water, crop, livestock, energy, many resources, and how people manage their farm, their field, for example. And all decisions depending on the type of the input, the processes, and the output, and the system can be diverse from West Africa to East Africa or South Africa. So in our continent, we have 50, as I say, and many. For example, if you take here, if you take in West Africa, we have 8 agriculture production systems, mainly about agroforestry and pastoral and fairly about crop. So according to FAO, the World Fund Program, this diversity of farm system in Africa is related to different climate area, and this allow smallholders to adapt to the environment changes. So as I said, the system help smallholders to adapt to climate change. So there is many elements, but here we talk about two couple of elements. The first one is temperature and the drought. So this couple of elements impact the different farming system. Here you are the plots that show the temperature variation from 19 to 2012 on the left part here. Let me put here, okay. And some RCP scenario of temperature change. So we know that drought become more common, especially in our tropics since 1970, and many research show that by 2080 in the future, the proportion of arid area and land in Africa will increase. So under the scenarios and in reality, when we travel in Sahel, for example, we found that this kind of situation start many time ago, and maybe we try to overcome this situation by some project like Great Hall. Also, uh, many research show that natural resources and crop failure due to the drought situation, and sometimes there is many conflicts in uh, in Africa between uh, nomadic herdsmen and farmers. You often hear about conflicts, maybe every year through Africa between uh, uh, our our parents, farmers, and elders about about the resources like biomass, water, whatever. So the second element is rain and water. Uh, by the way, I like this article from International Agency of Atomic, whose title one of the article as "No Rain, No Food." And without water, crop die, farmers lose their income, and people go hungry, and there are many disasters. As there are two type of cropping systems, namely irrigated and rainfield. For example, in Africa, we know that our agriculture depend upon rainwater, and it represents about 60 to sometimes 80%. Uh, so this is important element for our agriculture, as we need water to grow our crops. So this plot show the water availability in the future, and what we can observe is that in the future we're gonna have a very huge problem against the resources. Even our the river, the rainfall variability in most countries, the really problem we face with. So the access of the water may be the bigger issue in the future, and the prediction of some research center talk about some kind of war against country about their river, their lake, for example. And as uh, African population is growing, access to water may be the biggest problem. In this temporal variability of the rain has a huge impact on biomass production. If you take there's two pictures, you can match them, and you find that as the as there is an variability in the season of rain, for example, uh, we can find that there is the same problem about the potential biomass production, especially in West Africa. Deal with the situation. There is a tool, they call it GeoGlam. It's crop monitoring tool that serve an warming alert in the earlier season for many research center. So we can see that in East Africa here. Okay, any problem? So in the East Africa, the development of the main but if we come here in West Africa, there's many the rain, drought, because some problem, livestock product will decline, leading to fluctuation in market. So, for example, for milk, for meat, productivity will not be the same in the future. To deal with there's different problem, so several solutions are set in place. Here we are a plot that represents the solution at scale of field. So we can split this map in two parts. The first, technologies and practices, different actors set in place to overcome climate change. So in this first part, we found many techniques such as diversity, choices of crop variety, best variety to adapt to climate change, the development of some techniques in agroforestry systems, mixed cropping, intercropping system between cereals and peanuts or beans, for example. Also, we have tools for observation and climate forecasting to prevent any events in the future. So they help us to understand the future climate and to take decision maybe before the raining season. So through we have also some policies initiative from government, NGOs, some actors, and this allow us to have some communication and sensibilization initiative, and that's help us and small orders to overcome or to prevent some situation. So here you have what kind of techniques we can use at the farmer level scale to adapt to product more in sustainable intensification way. So this concludes my presentation. Thank you for attention. Your questions are welcome.
Okay, thank you, Espoir, for your presentation on the impact of climate change on the farming systems. Any question?
Yeah.
Okay, go ahead, please.
Yeah, I'd like to thank the presenter for the wonderful, insightful presentation. Yeah, I must confess that the presentation captured virtually most of every aspect of part of climate change farming systems. One area I want to talk about is on policies.
Okay.
Yeah, and not necessarily direct me to the presenter alone, but to each and every one of us who may have a better answer. Considering the presentations, the projections by 2080, the proportion where he said that the proportion of arid and semi-arid land will increase by 5 to 8%. Yeah, I think this poses a very big problem. What I'm saying, well, my question is, prepared for the challenges ahead? Or do you think they are doing enough? Because one of the problems we are having is that this problem, the issue of climate change impact on farming systems, is going to hit the resource poor farmers the more. They are going to be the worst hit. And I don't think most African countries are well prepared for the challenges ahead. So this is going to be a very big problem for us. So I wanted the presenter to share a view, what he feels, what he thinks about this. Yeah. Secondly, he talks about interdisciplinary research. Yeah, that's the way to go if we must, come out of this problem. Thank you.
Yes, Paul. So I'll let you answer Emmanuel questions. So it was about, I think, the level of preparation of, I would
The
say, our
preparedness of
government.
African countries for the challenges imposed by climate change.
Yeah.
Yeah, I agree with you. You're right. We are not so we don't so prepare for this problem, but I'm very happy that many people know that agriculture in Africa is facing this type of problem. And as I say, I work in a research center, and we focus on agroforestry systems because we think that this kind of solution must help us to mitigate the effect of climate change. For example, we work on Abia parkland, and Abia, for example, is a tree with unusual phenology. So he has a reverse phenology, so he living out in dry season and he shedding in rainy season. So this kind of a system is very interesting in our continent, our area here, especially in Sahel. But I'm agree with you that we are not so prepared to this problem, and we do as we don't have enough enough I can say tools, maybe money for a project to set up at a large scale some solutions, some tools. So we do it at maybe at plus scale, at village scale, just to try to understand how the future climate will be before I don't know, doing it at regional scale. I don't know if you answer your first question.
Yeah. Yes.
So the second, I don't remember. Can you help me to?
Yeah, the second one is just a more of a recommendation anyway.
The recommendation.
Yeah, about interdisciplinary research. About the recommendation for interdisciplinary research, which I said is the way to go.
I don't understand your.
I said
Yeah,
in some of your mitigation strategies.
Yeah.
Yeah, you mentioned interdisciplinary research.
Okay.
Yeah, so which I just said, yeah, that is I just agreed with that anyway. Yeah.
Yeah.
Secondly, talking about, I'm happy with your work, the integration of agroforestry and the management of, when we're trying to look at how to mitigate the impact of climate change. But one other area I think we are having a very serious issue, like you mentioned, is, in West Africa and even in some sub-Saharan African countries, we have this crop livestock interaction, kind of, and then the use of biomass, the crop residues in feeding animals, and as fuel. So, which actually is a problem in in the organic matter storage in soils.
Yeah.
So you found that the soil organic matter in most of the arid, soil organic carbon in most of the arid and semi-arid regions of Africa is very, very low. And then when we talk about that, so if the soil, which is supposed to be a kind of a sink for organic, for that carbon, is not actually having enough. So it's a problem.
Yeah. Yes,
So I
it's
think,
really a problem.
yeah, it's a very big problem. So if you can integrate that agroforestry into the system, which will help in improving the organic matter storage, and then see how we can bring in more crops that are more adaptable to the area, and then find out other solutions for soil moisture conservation and retention. That will help improve on our farming system. But to be honest with you, the farming climate change is really giving a very big blow to the farming systems in sub-Saharan Africa. Anyway, that's my contribution for now. Thank you.
Yeah, I definitely agree with you. It's really a problem, and in the Great Wall projects they set up this year, and they want to contribute with reforestation. The main objective is to allow farmers and livestock to have feed, and at the same times we use I don't know, maybe I will promote my Fidebia tree here, but I think when we are in a dry season, we use their leaves to feed to feed livestock. So sometimes we pack it in the in our field, our farmers' field, and our research shown that if, for example, millet yield at above the crown is higher, tree higher than a distance of 3 radii, for example. So we use it at the same time we feed livestock, and we want to compare what will be the benefits in doing something like that. It's not easy because Fidelbia is a tree. So growing Fidelbia is we take you maybe 20 years. So we combine it with this project of Great Wall, and it will be a coordination. That's why I'm talking about interdisciplinary research centers, because if Senegal or maybe Mali or Nigeria, for example, do it by itself, climate is not simply for it's not only for Nigeria. We have a separate one, so we might combine uh, our equipment to understand how for example the weather is gonna be in 10 years, 5 years, or yeah. So we're gonna implement some kind of war to help our farmers. That's why I'm talking about interdisciplinary. We have SEALs who give us some prediction about the raining season. Is not that's good, but we must do something bigger. I think in maybe in West Africa, included countries from East Africa, because they are facing the same problem in Sahel. So we must refine our prediction too, because sometimes we got prediction, but is too large from the reality. So yeah, I'm totally agree with you. Thank you for your contribution.
Yeah, thank you very much for that presentation.
Okay, thank you, Espoir and Emmanuel. Thank you for your contribution and for the very rich discussion on that subject, very important. So fuzzy cognitive map are fuzzy graph structure for representing causal reasoning. The fuzziness allows hazy degree of causality between hazy causal objects. We will go into detail into all that. It has been created by a guy called Costco in 1986. You can also define the fuzzy cognitive mapping as a graph-based representation of a system, including interactions between components of the system. These interactions represent the impact or correlation between the component of the system. It can also be defined as a semi-quantitative mind map, allowing the representation of multiple interactions, feedback, and loops in complex systems. FCM is also a simple way to find, as I was saying previously, participatory solution to problem involving multiple stakeholders managing common resources with various viewpoints and interests. Now, what are the components of an FCM? Well, FCM refers to fuzzy cognitive mapping. So a fuzzy cognitive map is made up of concept. So the variable composing the studied system. You have the directed edge, which are the links between the concept and the weight that quantify the impact of the relation between two concepts. And the values of those weights varies between -1 and +1. So here I give you a very, very, very simple example of FCM. In my example, we have 3 concepts. Okay? You can even relate that example to the system representation that we did this morning. So we have 3 concepts: agriculture, forest, and biodiversity. I have 3 directed edge. The directed edge are the links. You can put it like that. You can also call them the links. And they are just those black arrows on the graphic, those 3 black arrows connecting the concept, okay? These are the directed edge. And I have 3 weights. So I have 1 weight here, -0.5, +0.7, and +0.3. So what does this simple graphic means? It means that agriculture has a negative impact on forest, okay? And I had evaluated that impact or correlation to be -0.5. Remember that the weights are always between -1 and +1. Now, if you see forest and biodiversity, there's a good correlation between them. So I affected that link, the weight is 0.7. Now, biodiversity, we know has an impact, a positive impact. It has a positive impact on agriculture. So I've noted it, I've given that link, the weight 0.3. So now how do we build a fuzzy cognitive map? First thing is that you need to gather information on the system you are working on. Then you go to the representation of the variables of the system. Next, you link the variables to represent the interactions. And then you go for some calculation. That the next step after the representation of the variables and linking the variables, you are now going to extract what we call the adjacent matrix. I will come back to that. And then after extracting that matrix, you go to the FCM calculation. After the FCM calculation, we are going to evaluate the stability of the FCM. Then the last step is the validation. I put it into quote. We'll come back to it also later, of the FCM. And if the FCM is not doing what we expect it to do, then you have to go back to the representation of your system. This means that there is something wrong with your representation of your system. So the first step is to gather information on your system. How do you do that? So you can gather useful information on your system through literature review or individual survey, allowing acquisition of both quantitative and qualitative information about your system. Focus group discussion with the different stakeholders involved in the management of the resources, and also quantitative measurement of certain parameters, for example, the amount of water in irrigation, soil quality parameters, available biomass per land use, etc. So that's for the first step, gathering information on the system. The second step is the representation of the variables of the system. So the graphical representation of the variable can be done in two ways. So the first way is that you gather all the stakeholders that are managing your resources in a focus group discussion, and each of them will draw, like you did in this morning, a mind map of how the system they are managing work, what are the different actors, what are the interaction between the actors and the resources, and what are the interaction between the actors. So each of them will propose something. So you have, maybe if you have 4 types of stakeholders, then you will end up with 4 different FCM, and it is now your role as a facilitator or researcher to harmonize all the viewpoint to have a global and final FCM. The second way is expert-based. So that one, you don't call all the stakeholders, but you do it based on your knowledge of the studied system. Now, representation of a system variables. You can end up with something simple like this. For the case of this workshop, I try to not include, because we will continue with the same example, not to include too many concepts for the exercise to become too fuzzy for you. So I retain some variables. So if when you come to the step of representation of the variable of a system, you have something like this. You see the different elements that you consider, the actors, the resources, and the interactions, you put them there. And then you go to link the different concepts or variables of the system that you have identified, you link them. So here, this is almost a fuzzy cognitive map, but I didn't add the weight. You don't see the weight there for you to see more clearly into what's happening. So we don't have a lot of concept here, but you can also already see that the map, the mind map of the system of a fact, this is a mind map of a system in relation to human health, is quite fuzzy already. It's difficult to read. That's why the methodology is called fuzzy cognitive mapping. Then the next step is the extraction of the adjacent matrix. Now, what is an adjacent matrix? The adjacent matrix is a matrix summarizing the interactions between the concepts, as simple as that. So if I consider the following FCM, okay, I have 4 concepts, A, B, C, D. Then I have the directed edge, okay, so the links between them. And I also have the weight, 0.6, minus 0.5. I choose to represent the negative link in red for you to quickly grasp the concept. So we are going to build an adjacent matrix for this from this simple FCM. So as you look at the table here that represent our adjacent matrix, you have from, you have to. So basically, how do you feel it? How do you feel an adjacent matrix? You consider from, for example, from concept A to concept A. It is called self-reinforcement because you're not moving, you are on the same concept. So if you look at A here, from A to A, you have that green arrow. I'll give you the explanation on the next slide. You have the green arrow of self-reinforcement that is there for the concept A. So from A to A, the value in the adjacent matrix will be 1. Still in the same vein, from B to A, if you look at the FCM, there's no arrow from B to A. So I'm simply going to put 0. From concept C to A, I don't have any direct arrow. So there also it is 0. From concept D to A, no link, so no weight, 0. Are you with me?
We can hear you.
Yeah, okay, perfect.
Yeah, I guess so.
Because next, we are going to fill the rest of the adjacent matrix together. Okay? So if I say from A to B, now from A to B, the value that will be here.
Plus, you're not including the weight.
Plus how much?
0.6.
Okay, perfect. Perfect. I like that. Now, from B to B. From B to B. So 0. Perfect. From C to B.
Minus C to okay, yeah, 0. 0.5. Because there is no value here.
All right. From D to B. D to B. D to B.
0.
0. Perfect. Now we go back here. From A again to C. So now from A to C.
0.
From B to C. From B
minus 0.
Minus 0.5.
Perfect. From C to C. Okay. And from D, okay. From D to C also is 0. Now, again here, from A to D. A to D, so from A plus how much?
0.4.
Great. From B to D. 0, correct. From C to D.
0.
How much?
0.
Please talk loud. I don't. From C to D. 0. Someone is saying 0 from C to D. Is it really 0?
0.2.
0.2.
0.2, yes, because you see the arrow from C to D. It's important. From C to D, 0.2. And now from D to D.
0. Okay.
0. Okay, perfect. So we continue. So now, more or less, you know how to build an adjacent matrix. So I'll continue again with the same exercise for you to, because this one is a bit more complex than this one. We go very fast. So from A to A. Okay. From B to A.
It's 0.
From C to A. Okay, perfect. From D to A. Now from A to B. Okay. From B.
0.
0. Perfect. From C to B.
0.
Yeah. From D to B.
0. 0.
It's from D to B, and it's 0 because that arrow is for B to D, not. Now from A to C.
0.
0. From B to C.
Minus 0.3.
Perfect. C to C.
0.
Okay, 0. And D to C is also 0. A to D. Okay, minus 0.5. B to D. Yeah, minus 0.7. C to D.
Plus 0.4.
Nice. And from D to D.
0.
Okay, perfect. So now the fifth the fifth step is the calculation of the FCM output. There are two ways of doing it. If you look at the literature, you find two ways. There's the linear one that we are going to use here, and there's the log one that we're not going to use. Okay, but both of them give more or less the same result. First, what you have to do when you want to calculate FCM output is that you need to define a state vector. Now, what is a state vector? A state vector is simply an initializing vector. So at the beginning of the FCM calculation, which is an iterative process, some concepts, especially the drivers, are given some non-zero values for the system to start. This allows the iterative process of FCM to start. What is a driver? A driver in your system, because you need driver in your system for the FCM to run. If you don't have drivers in your system can't run. A driver is a concept of the FCM with no incoming arrow. Okay, so in our example here, you will see that who can locate a driver in this system? The answer is there, it is A. Because if you look at A, there's no incoming arrow A. You see going from A to other concepts, but there's no arrow coming from other concepts to A. That's why we call A driver. And generally for drivers, but not only for them, you have this self-reinforcement. For example, an example of driver in the system can be the demography. So if you represent the demography in the system, you can set the demography to be maybe 0.3 or maybe 0.2, it depends on the growth that you want. And that demography is supposed to be a driver in your system, meaning that is a major cause of change in all your system. Great. If you have question about that, write it down and then we come back to it. Now, I said at the beginning that you need to define a state vector. So a state vector is just there for initialization. For example, in our example here, a state vector can be 1, 0, 0, 0. I explain. The one that is here is for the driver, because the driver at the beginning of the simulation always has a non-zero value. All the other concepts will have 0 value for convenience. You can change those values and you can give them non-zero value, but it doesn't change anything to make the simulation longer. But to make your simulation shorter, you only give non-zero value to your driver. Here, I choose to put 1. You can 0.5 or 0.2. It's up to you. Now, still in the calculation of the FCM output, I said previously that the calculation is an iterative process. Okay? Each step consists in multiplying the state vector by the adjacent matrix of the FCM. The result will be a new state vector with possibly different values. So I'm going to stick to our example, to the simple ABCD FCM, where A is our driver. Remember, no incoming arrow. So it is a driver. We said previously that the state vector is 1, 1 for A, 0 for B, 0 for C, and 0 for D. Multiply by our adjacent matrix that we defined previously together. So how do I do this calculation? Very simple. I choose the first element of the state vector, which is 1, and I multiply it with the first row of my adjacent matrix, which means that I multiply 1 by the first line, which is 1, 0.2, 0, and 0.5. Now I multiply 0, which is the second element of my state vector, with the second row of my matrix. 0 multiplied by 0, 0, minus 0.3, minus 0.7, plus 0. So the third element multiply by the third row, 0, 0, 0, 0.4. And then the last element, the fourth element, 0, multiply by 0, 0, 0, the last line of my adjacent matrix. When I do this, I'll have this result. So 1 multiplied by 1 is 1. 1 multiplied by 0.2 is still 0.2. 1 multiplied by 0 is 0. And 1 multiplied by 0.5 will still be 0.5. Now 0 multiplied by by everything else, here will give you 0, 0, 0 everywhere. So when you sum this up, how do you sum this up? You take the first element of the vector, the one that is here, plus the 0, plus that 0, plus that 0. In reality, it's just simple matrix multiplication. For those who are familiar with matrix or algebra, that's not a big deal. And for those who are not used to, don't worry. You don't have to calculate it by hand. I just want you to know the theory and the mathematics that is behind, because it's always served. So at the end, when you sum all these 4 vectors together, you get this 1, 0.2, 0, and 0.5. you have a new state vectors. And if you look at the beginning, the values that you have at the beginning of your simulation was 1, 0, 0, 0. Now, in this step of the iterative process, which is step 1, the new state vector that you have is 1, 0.2, 0, 0.5. And those are the temporary values of your concept, meaning 1 for A, 0.2 for B, 0 for C, and 0.5 for D. So the next step will consist in multiplying the new state vector. So this new state vector, we are going to multiply it again by our adjacent matrix. And we will have the new state vector. So you continue until the state vector values become stable. So once you went through the iterative process of running the FCM, the number of iterations that you use for running the FCM is completely your choice. And you can take 50 or 100 or 1000, it depends on your system. But at the end of your simulation, the following will occur. The first possibility is that all the values of your system goes to 0. In that case, we say that the system is imploding. Second, all value continue to increase or decrease, then your system is exploding. The third thing is that the values show a cyclical pattern, not interesting too. And the best case is to have the values that become stable, that do not change anymore after a certain number of iterations. Illustration. I know. First, if the FCM, this is what I was saying, if the FCM does not stabilize, this means that if the system implode or explode or show a cyclical pattern, then you have to go back to the definition of your system because you probably missed something in the conceptual framework of your system. That's why the system is not converging or stabilizing. So this is an example with, the result of this iteration with our basic system ABCD. So what you have is 1 is still linear. When you find in the interpretation of FCM a line that is from the beginning to the end, like this, flat and horizontal, then you can already know that this one is the driver of the system. Now for the rest, you can see that you have one positive, like you have B that grows and then becomes stable, C decrease, become stable, and D decrease a lot and become stable. Concretely, how do you interpret the results for this simple example? So you interpret it as, for example, B, the system that you are studying has a positive value for B, but that positive value is still low. So if it is a production, you assume that the system allows the production of the good you are studying, but that level of production is low. But on the other side, if you look at those lines like the gray and especially the yellow one, you can see that it is clearly negative. So for example, let's say that this yellow thing is biodiversity. This means that your system is decreasing a lot biodiversity, and if you continue the same way, then probably there won't be at the end any or very few biodiversity in your system. I know it can be a bit complicated to interpret because this example is not very concrete, but I just wanted to show you, based on the example that we did, When you run the simulation 20 times, this is the result that you have. The system converge, and you can assume that you have a good representation of your system. Now, the last step is the FCM validation. Problem is that there's no validation method per se for FCM. And the FCM result for the current situation, what you can do is to compare the results of FCM concept value that stabilized with the real observation. Then this gives you an idea of if the FCM is replicating what is happening in the system or not. So I'm going to give you some advantages of using FCM. Okay, it's simple. It's a visual representation of a system, so it's easy to understand by its stakeholders, even those that do not have, a high level of school degree. Now, participatory approach, because it can integrate multiple viewpoints. It's also an adequate tool to trigger consensus on common resources management. And lastly, its implementation is simple and adequate to explore participatory solution for common resource management. I think that tomorrow we'll go into exploration of FCM models, sensitivity analysis, all those things, and scenario definition. And you can see how you come up with possible solution to a problem. Now, I've added some case study, and yeah, we also have for the workshop a website that is been updated, and all these documents that I'm using in my presentation for farming system analysis, for FCM, for sensitivity analysis, and so on. You have all of them uploaded on that website, so you can download the materials. And if you're interested, well, so I'm going to present you a paper that is very famous and about physical cognitive mapping developed by Casper Koch on the potential of physical cognitive mapping for semi-quantitative scenario development. An example from Brazil. So if you look at this, actually, it is the representation of, this is the FCM, of course, and the representation of a system in which you have the key concept at agricultural expansion, okay, land use intensification, infrastructure expansion, but also you have many drivers like the policies, because if you look at policies here, you don't see any incoming arrows, okay? And you can see the self-reinforcement arrow here, +1. The policies, population growth, so demography is also a driver, and exportation also is a driver of the system. Now he tested 4 scenarios with his FCM, and I will show you quickly how you can interpret. The first one is for the current situation. So for the current situation, that big black line is for agricultural expansion, okay? You also have the demand and speculation, the infrastructure expansion. So if you look at the graphic, the first thing that you see that it is a system in which the agricultural expansion is important. And that's true compared to real life, okay? However, if you look at here, this line with the triangle here, you can see this is the line of agricultural profitability. The system is not really profitable because it stabilizes around 0. So it's a system that is not really profitable, especially to smallholder farmers. You can see that the demand here, the demand for agricultural products in the area is also important, as well as speculation. So what he did is to test the scenario of export restriction, because if you have export restriction, you expect to lower the demand on agricultural products. So what would have happened in that case, when you simulate with the FCM, you see here that this line that was here around 1.5 is now very close to 0.2 or 0.25. So guys, in this scenario, the agricultural expansion decrease as a result of the decrease of agricultural demand, okay? But the profitability of the system is still very low. So that scenario is not very interesting for smallholder farmers. There's another scenario about infrastructural restriction, because infrastructural development has an impact on the biodiversity, especially in Brazil, in the Amazon forest. So if you decrease infrastructural restriction, it doesn't change that much to the system. But now if you combine what we called multiple policies, which is to combine export restrictions, infrastructural restriction also, then you come up with something like this. Here you have the agricultural demand that is low. The expansion also is low. And the agricultural profitability start to be slightly higher. This means that this scenario will be a bit more profitable for smallholder farmers. Now, this is for the first case study. The second case study is the use of fuzzy cognitive map to predict sugarcane. Oh no, here is cotton, excuse me, cotton crop yield in precision agriculture. So what they did is simple. They represent the yield to be depending on a set of soil parameter like sand, clay, nitrogen, phosphorus, sodium, calcium, etc. So they link these elements to the yield, and they perform the simulation here for the FCM. You can see that the system converge and stabilize. And now they classify it because according to the value of the yield that is here in purple, according to the value of the yield given by the FCM, you can classify the yield as being low, medium, or high. So they use the FCM to classify or to calculate the yield given these parameters for 6 consecutive years. And that's the level of accuracy of classification that they found with the FCM. So you have around 70% of accuracy of classification, like the yield will be good, or the yield will be medium, or the yield will be low. Okay, so our first example, I hope it will not take time, is for you to extract the adjacent matrix and compute the FCM concept values in R and interpret the results. Okay, I will share with everyone the files that will be used. I hope that you have you all have R or R Studios installed on your computer. What I think I will do now is to simply put you, instead of individual work for this, to put you in group because you are running out of time. And I'll give you the script and also the data, and I'll show you how you can run everything and how you come up with the result and the interpretation. So first, let me share with you the link of a drive in which you will find all the script that we use in our workshop and also the examples. if you have questions, please go ahead.
Yeah. Hello, can you hear me?
Yes, I can hear you.
Yeah. My question is the last thing that you shared, second to the last, the published research work that deals on that relates soil yield to available soil properties.
Yes.
Anyway, I believe the paper is that because I would like to look at the methodology and find out whether they actually did some lab analysis and short to find out how they relate all those things, because I believe there must be values attached to each individual elements that help them to predict the yield. I don't know if you are getting what I mean.
Yes. I mean, I get what you say. This is what I was saying, like at the beginning. Like, you have to have a good knowledge of your system. The moment you have a good knowledge of your system, the way you build it, like if you fix the impact, for example, of nitrogen to be 0.7 in a region where the soil are already poor and lacking micronutrients, this means that at the end the soil is not very responsive to nitrogen. So you are representing, you are not representing with accuracy your system. But I can send you all the papers. All the papers will be available by tomorrow on the FCM website, so you can go through the paper. And if you still have questions, you can ask.
My question is, as regards how we find application outside agriculture in this fuzzy cognitive mapping, because I've been trying to.
I can't hear you clearly.
I'm trying to see how I can easily relate some other disciplines outside of agriculture, perhaps maybe with respect to parasitology or entomology. Are we going to look at illustrations or case studies where this has found application?
Okay, of course, because I am an agronomist, I have put some examples of the use of FCM for farm system analysis. But there are a lot of papers on the use of FCM on in the medical domain, in biology, and so on. I think I will look for some of them and add them to the literature, and so that you can have them available. But I advise you also, if you can go to Science Direct websites, and yes, because parasitology is not really my field of study, but yes, of course, FCM has been used for all these purposes, so you can find a lot of interesting paper about that.
All right, thank you.
Yes. I select this, that is there. I copy it.
Okay. Yes.
Now, I move to RStudio, but I'm not very sure you are seeing my screen.
I'm seeing it.
Are you seeing RStudio?
Okay, no, I'm not seeing RStudio.
Oh, no.
Okay, no problem. I will do a new share. How do you do that?
Yeah.
Okay. Can you now see my RStudio?
Yes.
Okay, perfect. So the first thing for you when you are in RStudio will be to open the files that are in your folder, all the files that end up with FCM that end up with .r. For example, you click on File, you click on open file. So file, open file, and then here you choose, for example, one. This is how it appears in my computer, R Studio file. Okay. So you select the R Studio file and you click on open. Are you with me?
Not yet.
Okay.
Okay.
Yes, to be clear. So you open it.
Okay.
Yeah,
Has everyone opened R or R Studio? Okay. Click on File, Open File.
Okay.
Now, when you open file, you go to the location of the folder that you downloaded on the drive, on Google Drive. The file that you downloaded, where they are, I mean, their location, you move to their location. And then you choose all the, I mean, one by one, all the files that end up with .r, like FCM function, FCM sensitivity visualization, FCM sensitivity visualization 2. Have you been able to import one file?
If it can work here. I'm ready.
With the important opening the file.
Did you open a file already? Has someone opened a file?
I've opened the file.
Okay, so I'll ask you to open all the files like FCM functions.r, FCM.r, FCM sensitivity visualization.r, and FCM sensitivity visualization 2.r.
I think I
Not good.
If you come to file, yes, it's okay. Okay, take all. Okay, all the files to .r.
Yeah, all the files.r.
Where you have FCM sensitivity visualization,
Yes.
FCM functions,
Yes.
making GIF.r.
Yes.
Okay, we'll open all of them.
Yes, you open all of them.
Okay.
That was it. Yes, sir.
And the color packages is regular.
All right.
Does it work or do you have a problem?
Yeah.
It works.
Yes.
Perfect. Does anyone have a problem with .r files? If you have a problem, please tell me. So can I assume that everyone could open all the file?
Yes, but except me, I'm recording. I couldn't open our studio because I'm recording what we are doing.
But you can't open it on someone else in the audience computer.
Okay, yes, I'm following someone else's computer, but in my own computer, I'm recording.
But did the person already downloaded the files?
Yes, I downloaded it.
Okay, so simple. You open RStudio. Did you open RStudio already?
Yes.
Okay, so you go to File and Open File.
Again?
You go to File here, top left, File.
Yes.
And you go to Open File.
Okay.
And then you go to the location where you've downloaded the files on the internet.
Okay.
Once you're there, now you select one by one. For example, select only one script, FCM,
Yes.
and open it.
Okay.
Does it work?
Yeah.
Okay, so you do this FCM functions, FCM visualization, FCM visualization 2, and making GIF.
GIF. I've done that.
Perfect. Okay. So the first thing to do, okay, I'm going to ask again. Does everyone have, for those of you who have RStudio, do you have RStudio open with all the files open in RStudio?
Yes.
Okay, perfect. What you're going to do is to go to the FCM function here. You go to the FCM function,
yes,
and you select everything that is here. Okay. Did you select everything?
Yes.
Now click on run. You have that button here. Run. This button. Click on it. Did you click? Sorry, I can't hear you.
Okay.
Did you? So you click on the button, huh?
Respond.
Okay.
Okay, nothing should have appeared. It's just execution of some function. It will just execute them with no results.
I'm getting lots of error prompts.
A lot of what?
Error prompts.
What you say? You say, or what?
I'm getting lots of error prompts. Error message.
Error messages. Okay, interesting.
Yeah.
So in which file are you? Are you in FCM function .r?
Yes. FCM.r.
Have you selected everything?
Run. Okay. I have two results. Exodata and data. But in the console, I have lots of error messages.
Can you please share your screen with us so that I can help you?
Yes.
Because I'm telling you to be in FCM function.r.
Okay, I think I ran the wrong. Okay, I ran the wrong one. Function.
So please start with FCM function.r. Select everything and you run.
Okay. Yes. I think
You don't have any.
No error message.
Okay.
Yes.
Okay. Now we are moving to the next step. If everyone is on the same, if we are all on the same level, we are moving to the next step. Now open your Excel file that is called example. Can you see my screen, the Excel file?
Okay.
Okay. So in the Excel file, the sheet called FCM. Go and select everything there and copy. Simply copy.
And copy it.
Yeah, just copy it.
Okay.
Have you all copied?
Yes.
Yes, we copied.
Okay, copy only the data, only the part where there's data. Don't copy empty cell. Only the part that is data, where there is data.
Okay.
Okay. So now we are going back to our R studio. Now we open the fcm.r script, fcm.r.
Okay.
Are you all there? fcm.r. Okay. Now you click on this line. The first white line where there is exo data, blah blah blah. Just click here. Okay.
Okay.
And click on run.
Okay. There's a data frame.
Okay. Does that work for everyone? Does it work for everyone? The first line. Who has a problem?
Me.
Okay. What kind of problem do you have?
It seems I did not that FCM.r. It seems I did not open it when I opened the other files, all the .r files in that studio.
Okay. No, it's simple now. Go back to file, open file.
Okay.
You remember, you go to file, look at my screen, go to file,
the FCM function.
Add open file.
Uh-huh.
When you are at the location, you choose FCM Not FCM function, FCM only. There should be a file called FCM. You have it. Hello. Did you find the file?
Oh, it's like I did not download it in the first place. So let me okay, fcm.r.
Oh. Yes.
Okay, just FCM, right?
Yes, just FCM.
Okay, it's here. Okay, it's here now.
So click on your EXO data, that line, the first white line, okay? And click on run. The first white line.
Okay, EXO data, yes. Yes.
And click on run.
Okay.
You have something happening.
Yes.
What happened?
Something came on. Down there, where you have jobs.
What?
Some luckily some values are kind of redress of that. That's something interesting. Okay, in the environment.
Okay, okay. Please go back to your Excel file. Okay, again.
Don't have add next method.
You say? Sorry, I can't hear you clearly.
It didn't come out.
What comes out?
Nothing.
Okay, so everyone, please look at my screen and write the same thing. Like write egg in the console here where I am here in the console here. Please go here and write exo data. Okay. Once you do that, press the enter key like this. You should have this table appearing.
Okay, go to where? Where you have
Excuse me. Do you have a problem?
Yeah, I think I'm not following for now.
Please share your screen with me, okay?
Okay.
Wait, I will stop sharing. Then you can now share.
Yeah. That's my screen.
Okay, let's go. So I want you to go to the panel where everything is blue. Okay, the console.
Okay, everything is blue, yes.
Yeah, click there, click there.
Up at the top.
Just
okay,
click.
yes,
there.
yes.
Okay, and then write exo data.
Okay.
And press the enter key.
Okay.
Perfect. This means that your importation is successful.
Okay.
Yeah. So I will please stop stop sharing so that I. Okay. Yeah. Okay. So okay. Yeah. So the second thing is to go back to the script here and click on the second line where you see exo edge mat. This line actually can compute the adjacent matrix for you.
Okay.
So when you are there, you click on run.
Yes.
Okay. Normally, you don't see any result, but again, in the console here, you're going to write exo adg mat. Okay. Do you see what I'm doing? Do you see what I'm doing?
Yes, exo.
Okay, write down in the console here, exo adg mat, and then you press the enter A. You have something like this. Does everyone have the same thing with me?
Okay.
You have the same thing?
Yes, yes.
Okay, perfect. Chinelo on your side and the people on the ground. Chinelo, are you still with us?
Yes, I'm here.
What is happening on your side? Is it all right? Do you have the same result? If you look at my screen, you have the same result.
It's one person trying to carry along, but we are on the same page.
Okay. Now, if you look at look at sorry.
Okay, please hold on. Okay, just give us a minute.
If you look at the result on the console here, you see that it's actually the adjacent matrix that we've built together.
Leaders.
Yeah.
I said, please, can you hold on just a minute? We are helping one of us.
Is there a problem?
There is a problem. We need to carry him.
Which problem?
Do you want to work with him? One of us is working with him. Okay. Okay, he's done. Okay, thank you very much. You can continue.
Okay. So if you look at small matrix here in R, you will notice that it is the same matrix that we have calculated together in PowerPoint.
Yes.
Okay. So what we just did is to take the data in a certain format in Excel. And then from this format, if you look at the data that we use, which is this one, it is just from a concept to another, and you have the column. So let's say it is in a long format. Okay. This format is very helpful if you want to build your FCM start with from what to what you write the associated weight, and after that, that function can compute the adjacent matrix for you. Do you understand?
I think you're having a different thing.
You say?
Okay, after that, did you run anything?
In the
After ESO, ADJ math, and then the other one comes in, data comes in, then you're having from group from to weights.
Wait. I don't hear what you're saying.
Where you are now?
Yes.
Where you are now, I don't think I'm there. I stopped at the upper level.
Okay, but are you here at least?
Yes.
You have this. What I did
Yes.
is simply that I have typed again data in the console, and I press the enter button. So I have this. This is what I have imported from my Excel. Do you have the same thing? It's not different, and we've already executed exodata previously here before we calculated the adjacent matrix. It's the same thing. Do you understand now?
I don't know if it's my keyboard, but it's working outside that environment.
I don't understand. It's working where? Okay, no problem. You don't need to execute this one, okay? Don't bother yourself with that, okay?
Okay.
We are going to continue. The next line, this one, please, everyone, be with me. The next line, this one is where, because in the first line, we have imported the data. The second line, calculated the adjacent matrix. Now we are going to use the adjacent matrix to perform the FCM calculation. If you look at the script, so there is a function that I have created for that, which is called FCM. And in this function, you give the adjacent matrix, but more important, you give the state vector. You see the state vector here? It's 1, 0, 0, 0, as we did in our example. Okay? And here, n iter is just the number of iterations. I choose 20 iteration because it's quite simple FCM. For other FCM, you need to go to 100 or more. And I want you to click I want you to click here and to click on the run button. Click here and click on the run button.
Yeah.
Okay. Jesus. Okay. Do you have a result?
A plot.
Okay. Thank you. I have a small problem with, I'm going to fix it. With, so you have a plot. It's not a very elegant plot. It's just a plot for you to visualize. You can do the rest in Excel. We'll see that. Okay, so you have to do now, if you have the plot, is to execute these two lines, right table, right table. You execute both of them. So you click on the run button twice. 1 and 2. Okay. I guess I can continue. Now your files has been exported, and you need to find where they are, of course. Generally, if you are not working on a project, if you look at your document folder, you should see them there. FCM example.txt, adjacent matrix example.txt.
Okay, it's a notepad, right?
Yes, you can open it with Notepad or even with Excel. It's better for you to Excel than that. And inside, okay, does everyone have already executed these two lines?
No.
Why?
Like it's giving me error message.
Okay, share your screen, please.
Can you see my screen?
Okay, I have to stop. I'm sorry. Okay. What is the error?
Now. Let's see. Okay, yeah. It's okay. You see, the error message there.
Okay, so it's perfect. Okay. Perfect. So I will start. Please stop sharing your screen. I will share mine and show you how you import the data into Excel and visualize everything. Okay, so I'm opening my Excel file. So what we're going to do is to create a new sheet. Okay. So click on the plus button and create a new sheet. Now you can go to, for you it will be here. Sorry, my office is in French, but here it should. Okay. Okay. Did you find the data button? Oh, no, is that
yes.
Okay. So here you go to test file. I don't know how it is written in English. Huh? You have something like this, or maybe you say?
Get external data.
If you external data, it will propose you many formats, like TXT and so on. Okay, please stop sharing my screen because your screen is in English. It will help everyone, I mean, all the rest to. So I will stop sharing and please share your screen.
Okay.
You can share. Okay. Good. So go to Excel.
Okay. Okay. Yeah.
I'm not seeing your Excel. It seems that you just choose to
Okay. Okay.
share your R.
Share the.
Share the. I mean, the first, when you want to share the screen, the first option, top left, if you choose that, then you'll be able to navigate.
Okay. Let me check. Share screen.
Okay.
Excel, right?
Excel, yeah. So yeah, now okay, I see. So does everyone, I mean, can everyone see this the screen?
Yes.
So when you created the new sheet, you go to data. Go to data, you go to get external data. I hope you all have the same thing. In get external data, you click on from test. Yeah, from test. And then, for example, you click on the FCM example, like that has been generated. And you click on import. Now all you have to do is just check that box, like my data has headers. There is a box there.
Okay. Okay.
Your data has headers, and you click on finish.
Finish.
Yeah. So you click on OK. Okay. So there is a small, let's say, I mean, you have to move, you see the ABCD?
Yes.
You have to move them one step ahead to fit the columns. So select all the ABCD and then move them one step ahead on the same line. Yeah, you can click on B, where there is B. Yeah, and then past. Okay, perfect. Now you have, for the value of each concept A, B, C, D, you have the variation of the value for each iteration. The first column that is empty is for the iterations. Okay, so you can after select the columns, and then do your graphics of the evolution of the FCM values through the iteration. Does everyone, I mean, are you still, are you all at the same level with us?
Yes.
Okay, perfect. Last step, maybe just select the column B, C, D, and E together.
B, C, D.
Yeah, the column B, C, D, and E. The columns.
Okay.
Yeah, select all of them, B, C, D, E. Yeah, and you go to insert, and then you go to next to recommended chart, there is those lines. Yeah, no, not that one. The lines. Yeah, this one. Yeah. Click on it and choose. Yeah, that one. Okay. I'm not very sure you clicked on the good graphic, but that's not a problem because it's adding up things. But then this exercise was just for you with the hypothetical and very simplistic FCM to see the process from R to Excel in which you can extract your adjacent matrix, compute the FCM values, and also make your easy visualization. Were you all able to do a graphic with the data? Who didn't come to the graphic step? Please let me know.
We are dead.
Okay, perfect. Perfect. Okay, so that was the first thing. I think now we are going for a 5-minute break. Then we come back for group exercise.
Okay.
So let's say that we come back at 35. So from concept A, the weight is 1. From concept A to concept B, the weight is 0.2. From concept A to D, the weight is minus 0.5, and so on. So this kind of format helps you to quickly transform your FCM, the graphical presentation of the FCM, into a table, something like this. So once you have it, what you do is that you copy your table, then you go to R Studio. So in R Studio, the first thing that we are going to do is to import the data into our environment. So you can see here, load example 1 data.
Because it's already popular.
And you run, you click on run. If you run, it will import the data. If you want to visualize the data, it is simple. You click on the console here and you type the name of the data, which is exodata. In my case, you push the button.
You type it and run.
And then
And
You
enter.
have it here.
You see that it's already there. It's already imported.
This is what we have copied from our Excel file. Now, the next step, as I mentioned in my presentation, is to compute the adjacent matrix. For that, the second line will be helpful. Okay, I click on the second line, and that is already done. Because my data are very short and small, it doesn't take time. So if I want to visualize what I just calculated, I do with the same thing with exodata. So exo adg mat, and then I validate. When I validate, I have this matrix, adjacent matrix of my data. Okay, and remember how if you refer to the file, like to the lecture that we did today, you can easily understand how this is built, because we did it together. It's not complicated at all. And then after that one, you go into the third step. The third step is the FCM calculation. And the FCM calculation means that you need your adjacent matrix, which is this one. You also need the state vector that like the state vector is the vector that starts the simulation, okay? And in this state vector, only the drivers should have non-zero value, okay? For the system to converge quickly. So here, A is my driver in my system.
Yes.
So I've put that A to 1, to value 1, and all the other concepts, B, C, D, to 0, 0, 0. I specify that I'm doing 20 iteration because I have a small system. If I have a big system, I may need 100 or 1,000 runs before the system stabilizes. Okay. Then I click here and I run the line. So basically you have a plot coming up. I think the plot is a bit problematic. There should be a problem in the code. I will fix that. Well, so you can have the result of the FCM here already in R, or you can export the result if you want a better or a simpler visualization. If you are not familiar with R, then you export your results. For example, here I'm exporting exo adjacent matrix here, which is the adjacent matrix of our example one. And I'm also exporting this one, which is exo FCM. It contains all the values of my concept at each iteration. So I run and I export it. This is the end in R. In R, this is the end of our script, the part for example one. Now what I have to do is I go back to Excel again. And in Excel, I create a new sheet. Here in your computer should be data, depending on the version of Excel that you're using. But it should be data here because your computer are in English. But depending on the version that you have get data from external source or something like that, as we've seen previously. So you click on get data from test source. In my case, in this version of Excel I'm using, the text file is notified here in data. So I click on it. And when I click on it, I simply go to the file that I have generated, which is FCM example, and I click on import. Here, I tick this box. My data has headers. This is what will be displayed in your Excel. And I simply click now on finish. And it will ask me, where do I insert the table? I accept this cell, and this is what will happen. Now you can observe that the column names are a bit, they do not correspond to the column. Okay, you have to take the data A, B, C, D and move them forward once. Here, actually, it is the iteration. So the first column is for the iterations, the number of iterations, 20 or 21. And for each concept, you have the value at each iteration. For example, at iteration 1, where we have the state, you can also call it iteration 0 because it's just the state vector that is here. And then when you do the first multiplication, matrix multiplication, you have this one, as we saw in the PowerPoint. And then the second one will give you the numbers, the third one, and so on. If you want to visualize, you just select those columns, you go to insert, and you click here on the recommend graphics, next to the recommend graphic here where you have the lines, and you click on the second on the first column, the second one. If you from then it's up to you, and because you are choosing the colors and the style of your graphic. So you have something like this in the end. You can choose to add title to axis and also to the graphic and so on. But you have something like this. This is, of course, a very, very simplistic system, but the objective was just to help you to see how it works. And from then, I will continue to the introduction of the work that we'll do tomorrow. So tomorrow you will be in group, but I will run the step again for you to completely be used to. And then now what I want you to do tomorrow will be to use this concept, already generated concepts. So you make group of people, make the group, and then you use these concepts, you connect them to form your own FCM. You connect them and you give to each connection a weight, positive or negative. The weight must be between -1 and 1. And then based on your graphical FCM, you will generate, you will write the Excel file like the one I've used in this exercise, something like this, from concept A to concept A to B, and so on. And you give the associated weight. Then you will have to copy this, go into R, run the analysis, and see the result. Now, if you have the result, you can copy and paste the graphic in PowerPoint. And the 1 or 2 groups, not all the groups, we have to present the results with a small interpretation. This is basically what we're going to do tomorrow in the morning. Do you have any question?
All right. That's wonderful. The second refresh or recap, that's that right. I got it for now, and I hope I will return it by tomorrow. So thank you for that wonderful presentation and also for your patience.
My question is, I'm still trying to figure out, perhaps, I don't know if you throw more light on it by tomorrow, as regards creating FCM from the data you showed, I think the example you showed.
Yes.
Giving us those, I think, the forage, the fertilizer infrastructure, I think the systems, the farming systems also. I don't know. I'm trying to figure out how we move from there to the FCM table you showed us in Excel. Giving weight to, I think we are supposed to assign weight to it from just these the pictures we see, if I'm getting you correctly.
Yes, from
that's what we're supposed to do tomorrow. From this, we come up with that Excel table that has weights, right?
Yes, yes.
So that is my question as to how we jump from here to there.
Okay, it is very simple. You have those concepts of variables that you need to connect. Okay.
Okay.
Then, to show the interactions that are happening in the system. For each interaction, you give graphically some weight. You see, to each interaction. If you want, I'll share. Let me share my screen with you again.
Okay, please.
PowerPoint, eh? So, you see, simple FCM that I draw here. You can see 4 concepts that I linked together. And for each link, for each arrow has its weight. For example, this blue arrow between A and B is 0. Do you see?
Yes.
Okay, perfect. So keep that 0.2 in mind from A to B. So now when you go to Excel, what you do is that simply that you write from A to B, the weight is 0.2. Do you understand?
Yes.
So this is what is written here. From A to B, the weight is 0.2. From A to D, the weight is 0.5. So I will give you additional tips tomorrow to go faster. Okay?
Okay. What I was actually asking is, before this, I think you showed us another set of data that had forage, fertilizer, infrastructure, subsidy, crop production, all those listed. Yes, this.
Yeah.
So I was wondering how we move from this to that graphical interactions you showed.
Yes, this is what I'm telling you. Okay, you have this system that is, those elements are elements of fictive farming system, and there are other elements that are linked to human health. I gave an example that I did myself here.
Okay.
I'm trying to go back quickly. Not the best way. Okay.
Yeah. So we're supposed to do this by tomorrow.
No, you're supposed to do this or by tomorrow or tomorrow morning. But this kind of thing is not very, it's not as complicated as you think. You just start with subsidize or anything, and then you start drawing lines. This is connected to this, is not connected to this, and at the end, you have something like this. And this is why it is called fuzzy cognitive mapping, because at the end, you have something that you yourself, you cannot easily read through. Okay, so what we can do is before the exercise tomorrow, I will open a PowerPoint file, okay? Pick up some of these concepts and connect them together, give them weight, and you'll see how it can be done very easily. Okay, we'll do.
That would be better.
Okay, no problem. That also works.
All right, thank you.
Okay. Yeah, you're welcome. So, any other question?
You're not here again.
Any other question about what we did today, about farming system analysis process, the methods, about the presentation of ESPOA on the climate variability impact on farming system in sub-Saharan African countries? Do you have any question about the FCM? If you have, please go ahead. Otherwise, we have to stop the session for today.
Oh, that's good.
So I'm going to thank you for your attention, because it's not very, it may not be very easy to follow all this in one day.
Okay, thank you very much for the presentation. I really learned a lot.
Thank you, and have also a nice evening.